The next few questions begin section 10.7, which is about solve and graph inequalities. So here we have an inequality. Q is less than -5. And our job, directions here say to graph this on a number line. So our first job is to find the number -5. So our number -5, and then to shade the part of the number line that makes it true. So let's check 0 to the right of -5. Does that make this true? 0 is less than -5? No, that's not true. How about numbers to this side? Is -6 less than -5? Remember, less than means to the left of. So that makes it true. So this is the correct side of the number line to shade. Alright, and we're going to shade towards the left, and we can either show this 5 with an open circle. I believe that's the way we're going to show it this semester, with an open circle. Okay, and shaded to the left. Now remember, if your variable comes first, you can trust the direction of your inequality to match the arrow end of the correct part of the number line. Okay, let's look at this next one. X is greater than or equal to -1. So first we find our marker number, -1. So here's 0, so this would be -1. And greater than or equal to -1. Greater than means to the right of, and so we would be shading to the right of -1. And do we include -1? Yes, because of the or equal to, that makes it true. That point makes it true. So -1 shaded to the right, including -1. And remember, again, you can trust the direction of that inequality as the same direction of the number line. Okay, let's look at this one. This inequality is a little different. Okay, it's a 3-part inequality. Because we have 2 inequality symbols. Alright, so sometimes we need to look at this as 2 separate inequalities. So let's read this one. If this were the only inequality we saw, x is less than or equal to -6, I'm sorry, that's +6, x is less than or equal to 6, then we'd find the number 6. Because of the or equal to, we would include it, a solid dot on 6. To the left of, then we're shading less than to the left. Oops, forgot the arrow on this number line. Alright, now let's take a look at the other part of the inequality. That would be the x and going this way. So it's easier for us if we turn that around and read it backwards so that the x comes first. If the x comes first, it's all backwards, so that would be x backwards. That would become greater than -2. X is greater than -2. So we find -2 on the number line and we leave it open. -2 and leave it open. And then we shade greater than would be to the right of. Now for the 3-part inequality, we have some shading in orange, some shading in green. And for the 3-part inequality, we only take the overlapping shading. So the overlapping shading would be this portion of the number line right here. Okay, so a brand new number line would show the number -2 and the number 6 with an open interval, open dot on -2 and a closed on 6, and the shading between. Okay, we graphed that one on a number line. Okay, this one we have the job to solve and graph. Okay, so solve and graph. Remember, inequalities solve like equations. unless we end up dividing or multiplying by a negative, then we have to reverse the direction of the symbol. And we talked in class about why we need to do that, because that shades the correct part of the number line if we reverse the symbol. We're going to divide by negative 15. Now, is that a cause to reverse the symbol? Yes, it is, because we divided by a negative. So that gives us x, and reverse this to less than, and this is a positive 3. Alright, now to shade that, we find the number 3, 1, 2, 3, and leave it open. Okay, and then we shade less than 3, which is to the left of 3. Okay, let's solve another couple of. Now on these we're not asked to graph. It says solve the inequality and state the solution set. Alright, so we'll talk about how to state the solution set without drawing a graph. So to solve this, like an equation, we want to isolate the variable term, so we need to eliminate the minus 5 with a plus 5 on both sides. So this zeroes out and leaves us with 6x is less than or equal to 19 plus 5 is 24. Now we're ready to divide both sides by 6. Alright, and there's no reason to reverse the inequality here because we divided by 6, not negative 6. So that isolates x is less than or equal to 24 divided by 6 is 4. Now, we don't want a number line for this time. We want to state the solution set a different way. So we could say the inequality says x is less than or equal to 4. And to show that as a set, we use set builder notation. This is what it looks like and how it reads. Use the brace and an x and a bar here. And then you repeat the inequality. X is less than or equal to 4, and you close the set with a brace. The way we read that is the set of all x values such that x is less than or equal to 4. Okay, that just says that shaded portion of the number line makes up the solution set for this inequality. Alright, let's solve this next one. Okay, a few more parts here. Solve the inequality and state the solution set, and we'll state it this way. Alright, so 9x minus 6 is greater than negative 24x plus 60. So I believe, let's see, we can't simplify anymore on each side, so we're ready to collect variable terms on one side. So how about we move negative 24x, or we eliminate it on this side, with a plus 24x on both sides. Plus 24x, plus 24x. Alright, that gives us on this side 33x minus 6 is greater than, the x terms here eliminate and we have 60 remaining. Alright, now we want to isolate the variable term, so we need to eliminate the minus 6 with a plus 6 on each side. And collecting like terms again, these zero out and we have 33x remaining is greater than 66. We're ready to divide both sides by 33. And that isolates x. There's no reason to reverse the symbol. Is greater than 2. Okay, do the division for 2. And remember, set builder notation for this would just say the set of all x such that, repeat your inequality, x is greater than 2, and close the set. That's what it looks like.